Okay, so we're very quickly going to cover this really cool time velocity conundrum sort of paradox that I recently discovered by working a little problem out. So let's say you're driving a car and your car covers this distance d, and you're driving at a velocity v1, and so your standard velocity equation is equal to v1 is equal to d divided by t1, right? And we can also rewrite that to say t1 is equal to d divided by v1. We're not going to use too many numbers here, but now let's say that your car did the exact same trip, same distance, except this time it drove at a velocity v2 is equal to 2/3 v1. So in essence, your car drove 33% slower the second time around, right? Now the question is, how long did it take you? What was the effect of you driving 33% slower on the time it took you to get there? So we do T2 is equal to D divided by V2, which we know is D divided by 2/3 V1, which is the same as saying 3/2 times dV1. D divided by V1 is just equal to 3/2 T1. So we see that T2 is equal to 3/2 V1, which is the same as 1.5 V1, which is the same as saying that it took you 50% longer. Now, that's where things get interesting. Even though you only drove 33% slower, it took you 50% longer to get to your same destinations, traveling the same distance. And I don't know about you, but I found that pretty interesting. It doesn't make, like, you would think if it was like a linear world. I drove, let's say your first trip was 60 miles per hour, your second trip was 40 miles per hour. You'd say, oh, I drove 33% slower, then it's going to take me 33% longer. No, it's not. Because apparently going slower hurts a lot more than you might think. Definitely more than I thought.